Hello everyone and welcome back. In this video we're going to introduce another class of functions. These functions come from certain combinations of the exponential functions which occur very frequently and are called the hyperbolic functions. We define the hyperbolic sine function to be e to the x minus e to the negative x all over 2, and the hyperbolic cosine is e to the x plus e to the negative x all over 2. And you may hear me call these functions sinh and cosh, which refer to hyperbolic sine and hyperbolic cosine. Now the reason they are named the hyperbolic sine and hyperbolic cosine is because they are in many ways analogous to the trig functions. The trig functions have a relationship to a circle, whereas the hyperbolic functions will have a relationship to the hyperbola. So let's take a look at the graphs of these functions as well as their derivatives. Now on the left is the graph of the hyperbolic sine function, which is given by this red curve. And the behavior for large negative values of x will be similar to the exponential function. Similarly, for large positive values of x, the end behavior of the hyperbolic sine function will be very similar to this exponential function. And on the right, we have the graph of the hyperbolic cosine function, again given by this red curve. And for large negative values of x, it will behave similar to this exponential function. And for large positive values of x, it will behave similar to this exponential function. So let's find the derivatives of these functions. So the derivative of sinh is the derivative of e to the x minus e to the negative x all over 2. And because the 1/2 is a constant, I can take it outside of the derivative. So we have the derivative of e to the x minus e to the negative x, which is multiplied by 1/2. So we have 1/2 times the derivative of e to the x, which is itself, so e to the x, minus the derivative of e to the negative x. Here we use the chain rule. So we have e to the negative x times the derivative of negative x, which is negative 1. So now simplifying, we have e to the x plus e to the negative x all over 2. And then this is just the hyperbolic cosine function. So now let's take a look at the derivative of the hyperbolic cosine, which by definition is e to the x plus e to the negative x all over 2. So we can take out the constant of 1/2 and multiply it by the derivative of e to the x plus e to the negative x. So that's 1/2 times the derivative of e to the x, which is itself, plus the derivative of e to the negative x, which is itself, times the derivative of negative x, which is negative 1 by the chain rule. And now simplifying, this is e to the x minus e to the negative x all over 2. And this is the hyperbolic sine function. And so what we have is that the derivative of sinh is cosh, and the derivative of cosh is sinh. And notice that unlike the trig functions, there is no negative sign when we find their derivatives. So now let's look at an identity. Recall that for the trig identity, we have cos squared of x plus sine squared of x is equal to 1. Now the hyperbolic functions will satisfy the identity cos squared minus sinh squared is equal to 1. And so let's prove this identity. So we'll start with cos squared minus sinh squared, which by definition is e to the x plus e to the negative x all over 2 squared minus e to the x minus e to the negative x all over 2 squared. So let's write out the expansion. So we have e to the x plus e to the negative x all over 2 times itself minus e to the x minus e to the negative x all over 2 times itself. So we will FOIL each of these terms. So for the first term, we have e to the x times e to the x. So what is e to the x times e to the x? Well, let's use our laws of exponents. If we multiply two terms that have the same base, then we add their exponents. So that's e to the x plus x, which will simplify to e to the 2x. So the first term times the first term is e to the 2x. Now what is the first term times the last term? So that's e to the x times e to the negative x, which by our laws of exponents, we have e to the x minus x, which is e to the 0. And so this will simplify to 1. Now the middle two terms is also e to the x times x, which will also be 1. And if we take the last terms and multiply them, we have e to the negative x times e to the negative x. So that's e to the negative x minus x, or e to the negative 2x. And so what we have is e to the 2x plus 1 plus 1 plus e to the negative 2x. And this is all over 2 times 2, which is 4. And we'll have a similar calculation for the second term. So we have e to the 2x minus 1 plus e to the negative 2x. And this is all over 4. So now let's combine our fractions. So we have e to the 2x plus 2 plus e to the negative 2x, and we subtract in brackets e to the 2x minus 2 plus e to the negative 2x. So here the brackets are important because the negative will distribute through the brackets. So if we distribute the negative, we end up with e to the 2x plus 2 plus e to the negative 2x minus e to the 2x plus 2 minus e to the negative 2x. And this is all over 4. And now let's cancel some terms. We have e to the 2x and negative e to the 2x. We have e to the negative 2x and negative e to the negative 2x. And so this will simplify to 4 over 4, which is equal to 1. And so cosh squared minus sin squared will be equal to 1. So now we can define the hyperbolic secant as 1 over cosh, and the hyperbolic tangent as sinh over cosh. Now let's use what we know about the derivatives of sinh and cosh to find the derivatives of these functions by using the quotient rule. So we want to show that the derivative of the hyperbolic secant is negative hyperbolic secant times hyperbolic tangent. So by definition, secant is 1 over cosh and here we'll use the quotient rule to find the derivative of 1 over cosh. So that's f prime times g. The derivative of 1 is 0, multiplied by the cosh of x, minus f times g prime, and the derivative of cosh is sinh. And this is all over cosh of x squared. So now let's simplify. We have negative sinh over cosh squared, and we're going to write cosh squared as cosh of x times the cosh of x. And now let's write this as two fractions. This will be negative 1 over cosh times sinh over cosh, which becomes negative secant hyperbolic times hyperbolic tangent. And now let's find the derivative. And now let's find the derivative of hyperbolic tangent. Hyperbolic tangent, by definition, is sinh over cosh. So here we're going to use the chain rule. So our f is sinh and our g is cosh. So the derivative of sinh is cosh times g, which is cosh, minus sinh times the derivative of cosh, which is sinh. And this is all over cosh of x squared. So let's simplify. We have cosh squared of x minus the sinh squared of x all over cosh of x squared. And from the previous example, we proved that cosh squared x minus sinh squared x is equal to 1. So this is 1 over cosh squared of x, which is hyperbolic secant squared. Now it can be shown that if we suspend a heavy flexible cable, such as a telephone or power line, between 2 points at the same height, then it will take on the shape of a curve that's given by the equation y is c plus a times cosh of x over a. So it will take on the shape of the hyperbolic cosine function. So now let's take a look at calculating derivatives that involve the hyperbolic functions. So let's find the derivative of x sinh of x minus the cosh of x. So for the first term, we need to use the product rule since we have the product of two functions. And so the derivative is the derivative of x, which is 1, times g, which is the sinh of x, plus x times the derivative of g, which is cosh. And then we subtract the derivative of cosh, which is sinh. Now let's simplify. We can cancel sinh and negative sinh, which gives us x times cosh of x. So now let's look at the function cosh of the ln of x. So here we use the chain rule. So we'll start with the outer function, which is cosh, and then multiply by the derivative of the inner function. So the derivative is the derivative of cosh, which is sinh, and we leave the inner function unchanged, and then we multiply by the derivative of the ln of x, which is 1 over x. Now in the next example, let's find the derivative of 1 minus cosh over 1 plus cosh. So here we use the quotient rule. So f is 1 minus cosh, and g is 1 plus cosh. And so the quotient rule, we have f prime, which is a negative sinh times g, 1 plus cosh, minus 1 minus cosh times the derivative of g, which is sinh. And this is all over 1 plus cosh of x squared. So now let's simplify the numerator. So distributing the negative sinh over 1 plus cosh gives us negative sinh x minus sinh x cosh x. And now let's distribute the negative sinh through 1 minus cosh. So we have negative sinh plus sinh times cosh all over 1 plus cosh of x squared. And now we can cancel the negative sinh cosh with the positive sinh cosh, and this will simplify to negative 2 sinh all over 1 plus cosh squared. And for the last example, we have sech squared. So here we use the chain rule. So we deal with the exponent first. So we have 2 times sech, and if we subtract 1 from the exponent, that gives us 1. Then we multiply by the derivative of sesh, which is negative sesh times tang. This will simplify to negative 2 sesh squared x times tang x. And that concludes our lesson for this video. In the next video, we will talk about implicit functions and the method for finding derivatives for these types of functions.